In this slide, we are discussing two topics. One is internet and second is the reference model. Internet is part of wide area network, but to show its importance, I'm talking it separately. We have defined already internet is a global kind of networks which comprises a very large number of networks, local area networks, wide area networks, number of connecting devices and a spread over countries, continent and so on. But here we'll provide some more kind of input. And then there is a reference model. Reference model is when we have to design a complex software. This is basic principle we follow in computer science, that when we have to design a complex model, then there must be proper principles applied to design. There could be thousands of modules. Each module will talk to another module. What should be interface? All the related functionality of a module will be part of that module only, not that something will be in one module, another will be in different modules. So there are well designed principles are there for designing complex software, and designing a network software is also a complex task, and this task is broken into number of subtasks, and what has to be done in each task are defined through different kinds of reference models. So we'll talk about the reference model, but again, just to have a brief discussion, briefly we'll discuss what we have already discussed in the previous presentations. There are many categories of network we have defined: personal area network, local area network, wide area networks, metropolitan area network. We define the characteristic of each such one. PAN is the simplest one. It is for individual person, for a single person. WAN is more complex, distributed, covers very wide area, and each has different kinds of protocols and purpose characteristics we have defined. LANs are private network and not subject to tariffs and other regulatory controls. MAN's geographical area falls between a MAN and WAN and local area network. The internet and satellite network example of a wide area network. We have also given you some examples of a metropolitan area network like cable networks, which is scattered, which is all over city. They provide the design for the providing cable TV, but today they provide you internet connectivity also. So example of a metropolitan area network. It does not go beyond a particular city. Networks are not designed in isolation. This is the trend today. Earlier computers were designed in isolations. One computer did not have any connectivity to another. Now we are talking about networks are also not designed in isolations. They are connected among themselves. One line is connected to second line connected to third line, one line is connected to WAN, and so on. So complex connectivity is existing now. When two networks are connected, they become internetwork. The term is called internetwork, and this is also called internet. So internet today is not a simple hierarchical structure. It comprises many WANs, LANs joined by connecting devices. It is a dynamic networks. It's evolving rapidly, adding new networks, adding new domains, adding new protocols, adding more users, adding new kinds of services, and day to day is changing. Earlier there was only one or two kinds of services. Today have a video streaming, you can see movies, download movies, you can do many other activities which were not existing. So evolving day by day. Earlier it was confined to very few people. Now today you see everyone has internet connectivity. Different kinds of internet service providers existing. So this is a term is called. So when you have internet connectivity, you require internet service providers, and these internet service providers, according to their reach, are categorized into different kinds of providers: international service providers, national service providers, regional service providers, and local service provider. The internet today is run by private company and not by any government organizations. So no government owns the internet. It's a private body which runs the internet. Internet service providers connects countries together. It is the top of the hierarchy. international service providers. The term I have used them because international service provider, there is a national service provider, there is a regional service, and the local service provider. Let us start with what is the functionality and the role of internet service provider. It comes on the top of the hierarchy because it provides connectivity among different countries. National internet service providers jurisdictions are basically within the particular country also. They are backbone networks created and maintained by a specialized company, and they basically within the country itself. The backbone networks are connected by complex switching stations, also called network access points. So their design is bit. The national networks, they connect many kinds of networks around the country, and they use different kinds of. They use backbone networks for connecting these different kinds of LANs, and sometimes they call network access points. Regional internet service providers are the smaller ISPs connect to one or more national ISP. So regional service provides, they have a connectivity to the national service provider. National service provider have a connectivity to the international service providers. But the regional internet service provider are basically a smaller ISP. They have a less number of users, because their jurisdiction is particular local area, connects to one or more national ISPs. Local internet service provider provide direct service to the end services. So the hierarchy is there. The local ISP can be connected to the regional ISP or can be directly connected to the national ISP. So that way one can think of it. So not only one is providing the services to all over the world. So there are different kinds of internet service provider. The players at the national level, international level, regional level, and local level. But finally, when you get a internet connectivity, you get it from the local internet service provider. Now move to the second part of my talk. This is called the reference model. You know that network is a combination of hardware and the software. In fact, so far we have been talking about the hardware itself. We are not going to talk about software at all. Just like operating system controls the hardware, memory, I/O devices, and then they control this central processing unit. So similarly, there is a software, network software, which controls the network devices. They recognize the routers, they recognize the network interface cards. To reduce the complexity of network design, most networks are designed in several layers or several levels. And this is the design principle of designing a complex software in computer science. Not only the computer networks, but also other areas like, for example, operating system design or the database management system design. They are designing in terms of number of layers or number of modules. You can say that this module works at the lower layer, some modules are called at the higher layer. We don't say the layers, but large number of modules are there. In case of 7th layer network design, the 7th layer will be built upon the 6th layer. 6th layer will be built upon the 5th layer. So that way they design itself. So each layer has certain kind of functionality, and they provide services to the higher layer and take the services from the lower layer. And all the functionality related to particular layer are confined to that layer only. So distinction is in terms of what functionality you are offering to them. All services on the top. So you can have n number of services. So services can be given, will be provided only from the top layer. The second point which you have to understand, the layers are designed in such a way that each top layer is built upon the next layer at the bottom side. 7th layer on 6th layer, 6th layer on 5th layer, and so on and so forth. One network differs from another in terms of numbers of layers, contents, function of each layer. So there could be different kinds of network design, and they differ in terms of these parameters. Layer n on one computer talks to the layer n on. So when we are talking about network, we are talking about communications. By default, the functionality of network is to carry communications. So layer n on one computer talks to the layer n on another computers. So you are sending a mail service is on the top layer. You will send a mail to the top layer of another machines which will receive your email. So layer in on one computer talk to the layer in on another semester. Data is finally transferred by the bottommost layer in form of signal using physical medium. The point is virtually they talk to peer layer or peer processes on that layer related to that surface. But finally, but in what we have discussed already as a part of data communication, data is actually transferred by the bottommost layer in form of signal using physical medium. And there is an interface between each pair of adjacent layer. It means the sixth layer has interface for the seventh, fifth has for the sixth, fourth has from fifth, and so on. So this way there is interface. It is basically not a physical, but it is a point which they have to use this one for accessing these services now. So accessing, if I have to send email, so there is a point, there is a function. I have used this function or this folder or this link for sending the message to another. So this is called interface, or you can say link. What type of primitive operation and services to be provided by the lower layer to upper layer are defined by the interface. So interface defines that what kind of services a lower layer will provide to the upper layer. So this way is defined. So there is separate link for the email, there might be separate link for the another kind of services, and this link is interface. So what kind of each link defines particular kinds of operations and services. Network architecture comprise of a set of layers and protocols. We have been defining the terms network architecture, but now when we see from the design point of view, we can say that any network architecture or defines a number of layers and protocols at each layer. So this by network architecture we mean by this. A protocol defines, we'll use this term protocol quite often. Protocol defines a set of rules and conventions required for communications. And finally, there is a software which will follow these rules and convention. Why require rules and convention? Because of interoperability. You move data from one machine to another machine. If the rules and conventions are not followed, then data will not be understood or interpreted at that point. The reference models are conceptual framework to define number of layers. That conceptual framework, they are not a physical framework to define number of layers, the functionality, protocols, primitive operations and services. The overall objective is to facilitate communications between a network. Two kinds of reference model we are talking about, the OSI reference model and the TCP/IP reference model. The OSI stands for Open System Interconnections Model. It is abstract model. It is not a physical model existing. It defines only rules, regulations, number of layer, functionalities, specifications for protocols. It is abstract model for understanding and designing flexible, robust, and interoperable network. What is term is interoperable means something. If I am sending an email from my machine to another machine, they must be able to understand what is that email, able to download properly. It is not a protocol also. OSI reference model is not a protocol, simply model, architecture, theoretical architecture. The OSI model defines network architecture into 7 layers, which from top to bottom are the applications, presentation, sessions, transport, network, data link and physical layer. These are the basically referred to as a OSI 7-layer model. A layer is a collection of conceptually similar functions that provide services to the layer above it and receive services from the layer below it. So you have understood. So layer could be one such module in a complex systems now, and all functionality related to particular layer could be at one place. You will understand this basically at a later stage when we define functionality of each layer. So these are the 7 layers. Again redefine. Applications layer comes on the top, physical layers at the bottom side. In between you have presentation, session, transport layer, network layer and data link layer. So each layer has different functionality. So all functionality of a data link layer will be confined to data link layer only. And on the top of applications layer is the users. At the most, the bottom part of the physical layer, it will be basically physical media. So physical media is the media through which physical layer interacts, and the user basically interacts with the applications layer. Applications layer for user interactions enables user to access the networks, supports a variety of application level protocols. This is a widely used application protocol called HTTP or SMTP. SMTP, so when you send email, then SMTP will be used. When you surf the web, net, download a particular page, you use HTTP. All browser uses this kind of protocol. Presentations layer, this layer is concerned with the syntax and semantics of information transferred between the two systems, converts data into suitable format. So required to do formatting, and that is done part of the presentations layer. It also does tasks like compressions, decompressions, encryptions, decryptions. Compression is required when you are sending very large file. If you don't compress, then it will take lots of time. So you have to compress it so that a smaller file size will reach faster than the bigger file size. You require compression, and decompression will be done at the another side. You also hide the message so that it cannot be hacked. So all the features are there available at the presentations layer. Then session layer, it establishes sessions between users working on different machines, responsible for keeping track of whose turn is to transfer data. It also does synchronization. Synchronization means that it adds a checkpoint for long data transmission. It helps recover data where from it crashed. Sometimes you have seen now, while booking a railway ticket or the airline's ticket, system gets crashed. Now when system recovered, it should start from that point where from it was crashed, and the term is called checkpoints. The transport layer, the primary function is to accept data from the upper layers, break into smaller units if required, and transfer to the network layer. Ensures that the entire data in terms of pieces received correctly in the order at the receiver end. The network layer is responsible for delivery of data from source to the destinations optimally and dynamically. What do you mean by optimally? Means there could be thousands of routes available from one machine to the another machine, destinations machine, when you are sending data. Which route is optimal in terms of number of less distance, for example. There could be thousands of distance point, but you have to find the distance which is minimum distance through which it can receive. We say sometimes hops. And dynamically, it might happen that you have selected a route, but that route is highly congested route. It always happens. The shortest route is always congested because every traffic is diverted, wants to move through the shortest route. So in that case, what happens if the it is a congested route, then they have to redirect the traffic. So you have to recompute the different optimal route. All routers work at this so router has a functionality to work at the network layer. Internet protocol is a standard protocol. In the transport layer, we have two kinds of protocol. If you just go back here, I think yes, transport layer, the two protocols are there. One is called UDP protocols are there, and there is called TCP protocols are there. Two standard protocols are used here. Come to data link layer, responsible for moving frames from one node to another node. What is a frame? See, the computers, as data move from one layer to another layer, it is broken into the smaller parts, and at each stage, at each layer, some information is added with this one. Transport layer deals with end-to-end source and destinations. So is the case with the network layer. Although functionalities are different, but data link layer basically deals between the two devices only, from one machine to another machines. It also has features to detect and retransmit damage loss frame. Besides this one, moving the frames, it also has some other kinds of additional features which is called detect and retransmit damage frames. Also has access control, because many networks wants to access, many computers want to access the same kind of media, but who will be allowed to access the media at a particular point of time is called access control mechanism. So the data link layer deals with many issues. It deals with the error control, the access controls, and also responsibilities moving from one machine to another machine, one node to another node, or between the hop itself. Whereas transport layer and this one, they move from one machine source to the destination, and in between could be thousands of machines. The physical layer deals with mechanical and electrical specifications of the interface card and transmission medium. So far we have been talking about this one, physical layer itself. Our whole concentration was on physical layer. Data communication related topics all confined to the physical layer. We deal with the physical media. So suppose if I have to send a signal, what should be the voltage level, high voltage for one, low voltage for this one. So we deal with those kinds of issues, where higher layer does not deal with the signal level or electromagnetic waves. They don't deal with it. They simply deal with the logical information, whereas physical layer deals with the media, whether it could be wired media or wireless media. Just I told you that the users are directly interacting with the applications layer, and physical media is directly controlled by the physical layer. So these things you have to understand. Here we have given example. This example you have to read, that if I have to send some mail and how it passes through different layers and what changes takes place at every layer. This is what explained to you, that if I have to send the email, what happens at the applications layer, what happens at the presentations layer, what goes at the sessions layer, what happens at transport layer, network layer, data link layer, and finally what physical layer does. This physical layer, whatever data you want to send, email or whatever way, they translate them in terms of a signals and voltage level, and then they send data to the another side. You always remember one point, which is the focus discussion here, is that if I am sending an email to someone, it does not go directly. It goes through different kinds of layers, and then starts from the bottom to the top. You send from top to the bottom, and then another side from bottom to the top, then it reaches to the destinations. Then comes the TCP/IP model, which is we use today. The difference between two are significant, although TCP/IP model came much more earlier. There are lots of changes between the two kinds of model, OSI model and TCP/IP model. Does not match exactly with the OSI model which we discussed, but here also we have a layered architecture, and this is basic principles where computer science, all the applications are developed in computer science. Applications layer is there, transport layer is there, internet layer is there, host to network layer is there, and other layers are not visible here, they are not there. Application layer takes care of presentation and session layer, transport layer remains the same, internet layer also remains the same, but whereas the host to network layers comprises some other like data link layer and physical layer concepts. In fact, it does not define many specifications, but supports many kinds of protocols. That model does not specify this layer, point already told you, but it basically combines functionality of physical and data link layer. This is, I'm talking about the bottom layer. It supports all the standards and proprietary protocols, and it is the standard today. So all these, when you send the email and all these, the TCP/IP model is involved here. And the internet layer, this layer routes and delivers data packets similar to the network layer, and completely different. So basically it sends packets from one packet from one network to different kinds of networks. So job is to routing of the packets. Responsible for end-to-end packet delivery while maintaining routing, flow control, error control functions. Error control we discussed at data, this one. Flow control is also very important concept which you have understood, that sometimes there is a fast network, there is slow networks. So flow control is used to maintain some kind of equilibrium between the two. Example of this layer is the actual, so some of the standard protocols are there. And a standard protocol of this model is the IP or IPsec. These well standard protocols are there. Transport layer is very simpler to what we define, but two standard protocols are defined here, TCP and UDP. One is called connection oriented, whereas another is connection less. Protocol difference is only that when packet is to be sent, one establishes the connection and the second one does not establish the connection. Applications layer is same, it combines 2-3 layers. Application layer itself, presentation as session layers, and contains higher layer protocol like FTP, SMTP, and so on. And I told you that when you send the email, we use a standard protocol, and most of the browser support is called SMTP, simple mail transfer protocols. Just conclude now. Networks are not designed in isolation. We just discussed. Today, all networks are connected to another kinds of networks. When two networks are connected, they are called internet or internetworks. We define two kinds of reference model. Reference models are basically conceptual framework to define number of layers, functionalities, protocols, primitive operations, services, and also made a point that TCP/IP model is different from the OSI models. Thank you.